All right, you guys got the most flattering angle of me here. Dad bod all day long. So this is about absolute value. So I'm not sure how IXL is going to teach it. I'm going to teach it two different ways. It deals with what we call the complex plane. And when you talk about the absolute value of a complex number, you're actually talking about the distance from the origin on the complex plane. Now, what is the complex plane, right? That's the next natural thing to ask. Kind of like the XY axis. What rhymes with I? X or Y? That's it. That's the I-axis. I is imaginary, and the X-axis is the A, which is the real. So real numbers get plotted on the X-axis. The imaginary component gets plotted on the imaginary axis. So when I talk about the absolute value of 5i, I just go up 5 units. And there's 5i. 5i is obviously 5 units from 0, right? I can count it. So this is just 5 units from 0, or 5 units from the origin. That's all it is. So the answer to this thing is going to be 5. It'll probably be easy like that for a minute. Oh, I can't do that. Okay, so over here. I am 5 units away from the origin. Terrific. This one's very similar. Negative 8i. I'm just going to drop down 8 units on the imaginary axis. When these get harder, I'll show you a little formula. 1, 2, 3, 4, 5, 6, 7, 8. I'd be right here. I am 8 units from the origin. Still got it. That's the absolute value of negative 5. That's a real number, isn't it? So that's just 5. Sweet. All right, we have a complex number now. This is 6 minus 8i, the absolute value of 6 minus 8i, a complex number. So something has changed here. We'll use this as a teaching example too, obviously, to show you the easy way of doing this. It's actually just Pythagorean Theorem. I believe that was the absolute value of 6, take away 8i. To plot that point, I'm going to go right 6 on the real axis. Remember, this is real. 1, 2, 3, 4, 5, 6. I'm going to go down 8 on the imaginary axis. So I'd be right here. Oops. This is where I would be. This is the complex number 6 minus 8i on the complex plane. Now, some kids are going to like the way I show this example here. Some kids are obviously not going to. I can't fix that. But when you first learned how to find the distance of a point to the origin, they had you doing this. You may not remember it. They had you imagining there was a triangle, doing a little Pythagorean theorem. To get to this point, you went right 6 and you went down 8. That's what you did. And they said, oh, okay, that's my hypotenuse. So you did some a squared plus some b squared is c squared. So that's what you do here. 6 squared plus a negative 8 squared is c squared. So 6 squared is going to give you 36. 8 squared is going to give you 64. That's going to give you 100 being c squared. And you can take the square root of both sides. And you're going to get that your length is a positive 10. Now, a lot of kids might be like, well, wait a second, it's going downhill. The hypotenuse of a right triangle is always positive, even in trigonometry. We always treat that as a magnitude, as distance. It's positive. You are 10 units from the origin. Hopefully there'll be another one of these and I can show you a different way of doing this. Fantastic. All right, so let's go back and look at my previous example here. Another thing I could have done And just look at the numbers you plugged in here. You squared the 6, you squared the -8. All right? Your magnitude or your absolute value, your distance to the origin, is always going to be squaring the numbers and taking the square roots. So let's insert a new page here. Write that down. The absolute value of a complex number a plus bi is the square root of a squared plus b squared. That's all it is, because that's all we did. Think about it. We did a little Pythagorean theorem or distance formula, however you want to think about it. That's all we did. We did the square root of a squared plus b squared, nothing more. So let's see what's up next in that example here. It was the absolute value of 4 minus 3i, which is going to be 5, by the way. One day you'll be as quick as me. I'm going to find the absolute value of 4 minus 3i. And the absolute value or magnitude, it's actually supposed to be magnitude. I don't know why they're saying absolute value. But the magnitude of this thing is the square root of 4 squared plus, and signs don't matter when you're squaring, 3 squared. But it's going to be the square root of 16 plus 9, which is the root of 25, which is 5. Just a 5. And let's see if I know what I'm talking about. I do. Isn't it good? All right, so let's jump up, see if anything gets harder. And I noticed that it says in the text that you're supposed to simplify. So I'm going to jump up to one where we have to do some simplification. Hopefully I'll see one. That one requires simplification to some degree. It's going to be a radical answer. So it's worth doing. That's -1 minus 2i. All right, well, the absolute value of this complex number must be the square root of 1 squared plus 2 squared. That's simple enough. That's actually going to be the root of 1 plus 4, which is the root of 5, which does not simplify. You can't take the square root of this number without using technology. Even then, you're actually approximating it. So perfect distance is root 5. That one will take some simplification. That's going to be what, root 82, I think, looking at it. Oh, I didn't forget it. The absolute value of -9 plus I. Is it -9 plus I or -9 minus I? It actually does not matter. All right, -9 plus I. All right, so its magnitude has to be a 9 squared plus a 1 squared because there's a 1 in front of that I. So that's going to be the square root of 81 plus 1. You guys should know your squares by now, which is the root of 82. You may actually not be able to do anything with root 82. Factors of 82 is like 82 is 2 times 41. Those are both actually prime numbers. Some of you guys know what prime numbers are now. You can't take the square root of a prime number. And I can't think of anything off the top of my head that I can take the square root of that enters 82. So there you go. That one's done. Its factors are primes. Nothing you can do with it. Root 82 is as simple as it gets. I wonder why they have the I key there. That's kind of interesting. Makes no sense for that to be there. Probably just throw kids off. 25 and 9. It's 34. Yeah, doesn't simplify. And jump up, see if we can run across some that requires actual simplification. This one does. So good, I'm glad I saw it. The absolute value of 5 plus 5i. That's my goal. Remember, its magnitude, its absolute value, is going to be the square root of a, which is 5, plus b, which is technically 5, squared. So each of those can give me 25s. When I put them together, I'm going to get a 50. Now, another way of doing this one is thinking about how many 25s it took you to get 50. It took 2 of them. That's the root of 2 25s. And the root of 25 is 5. 5 square roots of 2. That's my absolute value. We'll do another 1 or 2 of these, and then I need to probably get rolling because I got a lot of stuff going on here next couple of days. And if there's more to do, I guess I'll record it from home. I'll be sure to put a shirt on. This one simplifies too. That is going to be the root of 20 when everything's said and done. That's negative 2 minus 4i, which will simplify. Magnitude of negative 2 minus 4i is going to be found by taking the square root of 2 squared. Notice I'm not even paying attention to signs, because if you square something, what does it become? It becomes positive, so just throw away the sign if you're going to square it. So 2 squared is 4, 4 squared is 16. I'm looking at the root of 20. It's time to simplify a radical. To get to a 20, you take a 4 and you multiply it by a 5. You should know that. If you don't, remember it. Right? 4 times 5 is 20. Root of 4 is 2. There's a 5 left inside that you cannot evaluate. You can't take the square roots of prime numbers. It just doesn't happen. So 2 root 5 is what I'm looking for. Now we're in the challenge zone. Anything interesting in the challenge zone? Nah, just more simplification. So this one's going to be a 90-95 goal. That's going to be the deal on this one, 90-95.